Hey, here we are. Next section, we're moving on to sets of real numbers, and we're going to do something called classifying, which actually we do a lot in science. We kind of classify things. Today, we're going to take a little math twist on it. So, as we go through this lesson, feel free to pause it at any given time so you can get caught up and do things, and I'll put in some suggestions of when it's a good time to do that. I'm wearing some funky red glasses today just to be different. Ha. So here's what I need you to do. This time, don't get scratch paper. I want clean, fresh, nice piece of paper. All right, we're going to do clean stuff. So if you need to pause the video, there'll be some somewhere in the front of the room if you need to use one of my pieces of paper or get your own out of your notebook. Okay, so pause if you need to. Now, we're going to test some of your beautiful artistic skills. Ready? I'm going to use pretty colors because black is boring. So what I need you to do on your piece of paper, I need you to draw a big hunkin' rectangle that's pretty much going to take the whole screen. And if you need to, feel free to even turn your paper or, landscape way versus this way. Okay, so feel free to do that. And then just inside the border, then go ahead and draw a big old rectangle. So I'm assuming what I've got on the screen here is what you're drawing within your piece of paper. So you just kind of pretend your paper's outside. So here's what we get to do now. I want you to put like a skinny banner across the top. And you can see I can't draw a straight line either. If you're using line paper, that might actually be to your benefit because mine's not so great. Then what I'm going to have you do is from here, we're going to kind of draw some space and then we'll get into labeling. I don't want you to draw a line straight down smack in the middle. I want you to make it a little off center. Okay. Like something like this. Okay. Do something like that. I'm double checking to make sure I've got this right. Then we're going to leave this side as is. I'm going to come into my bigger area. And if you could, would you make, if you want it to make it look like a nice oval, you can, but I'm just going to kind of make a fairly big blob in here, okay? And then do the same. That almost looks like a tooth, doesn't it? Weird. And then inside here, then you can kind of make another little general region, okay? So you got the big rectangle, skinny banner on the top, straight line, and then a couple of blobs in this larger region, okay? Now, we are going to do some specific labeling, and I'm going to start from the inside and work our way out. Inside this centermost piece, I want you to call this hole. Like, haha, it looks like a hole, doesn't it? H-O-L-E. Clever. These are your whole numbers, okay? Whole numbers. These are the numbers like 0. 0 is the first whole number. And then it's the counting numbers. 1, 2, 3, 4, and so on. So you can get about that far and then go ahead and put that ... Ellipsis, I think is what that ... is called. All right, so this is a set of numbers. There's an infinite number of numbers in that set, and yet it does not include all of the numbers in the world. It doesn't, okay? The next level out, so what I made is this kind of weird shaped blob. Here is what I am going to have you label the integers. The integers include these numbers, the whole, 0, 1, 2, 3. So I'm not going to write those again out here. They're already part of the big blob. They're kind of all congregated as their own little group or clique right here in the middle. But the integers include more numbers than just the whole numbers. This also includes numbers like -1, -2, -3, and so on. So I'm going to put a ... like that. Everything that's an opposite of one of those whole numbers is out here in this region, okay? So we've got whole numbers here, integer numbers here. And they're both infinite. And yet, there's more. Because what about all of my fine, fabulous decimal and fraction friends that aren't already accounted for in the blob? Holy cow, they're out here. And we've been talking so much about rational numbers. So here are all of my fine and fabulous rational friends. Rational number, any number that can be written as a fraction, where your numerator and denominator are integers. Okay, so if you can make a fraction out of it, it's a rational number. A lot of them are already included in there. Okay, like something like -8/2. That's really -4 in disguise. So just because it's written like a fraction, don't think it's out here. This simplifies to be exactly -4, which is in this area or this region. Okay. Cool, cool, cool. Now, as I'm looking at a lot of this stuff here, we can throw in a bunch of examples of rational numbers. Oh my gosh. The thing is, though, I'm not going to make a list where I include that ... because there's just so many rational numbers to choose from. So let's see here. I could put something like 1/3. 1/3's a fraction. It also could appear to us as its decimal equivalency, so that's 0.3 repeating. That would be in this rectangular box region. It wouldn't fit as part of the integers. It's not a whole number because it has this fraction or decimal component to it. Something like -6/7. That's going to be out here. Not an integer. I know you see that negative, but it has fractions. Okay, or that ends up being a repeating decimal, by the way. Let's see what else. I have something like, you could have improper fractions like 27/4 and 4 5/10. I mean, you could never get done here. We could fill that all up, but you get the idea, right, as to what this includes. All right, so those are all the rational numbers. Now, yesterday we talked about irrational numbers because, of course, it would make sense that if we have numbers that are rational, that behave kind of predictably, normally, logically, we've got these odd ones out here. Irrational numbers can't be written as a fraction. They're just strange. When we try to write them as a decimal, they don't repeat, and they also don't end. So they're this bizarre thing. World famous, most famous one that you probably can come to mind right away is pi. Okay. But now yesterday we talked about all these other examples that happen to use a radical symbol or the square root. So I'm thinking numbers like square root of 2 or the square root of 17. Okay. These are numbers, but I think square root of 2 is like 1.414, and it goes on and on. Your calculator shows you the first 10 digits, but what we've talked about is this is a weird number. It doesn't repeat, it doesn't end, and so that's why we like this notation to exactly represent it. Because when we try to write it as a decimal, you can't. It keeps going and it bounces all over the place, and it's just strange. Okay. Now we could also have some negative numbers here, like the negative square root of 11 or something like that. Okay. Together, all of the rational numbers, all of the irrational numbers make up real numbers. So this is what I want your chart to look like. Okay. Real numbers. Now, one other thing I want to add, and this isn't necessarily part of your book. However, there are weird numbers that aren't real. What? It's true. So if you have any room on your paper where we can put a few things outside the box, do something like this. Put a number like 4/0, because that's impossible to do. You can't do it. Okay? One second.